So I'm here today with Lukas Biewald, who is CEO and founder of Crowdflower. Lukas, welcome.
Thank you.
So I want to talk about your company for sure, but before I get into that, can you tell us your 60-second bio?
Sure. I worked on artificial intelligence at the Stanford AI Lab, and then I went to Yahoo and deployed machine learning models actually for search relevance all around the world. So we were switching from hand-tuned weights to machine learning, which was a really fun time that I think other companies are kind of going through now.
Exactly.
Yeah, and then I got my first job in a startup, and I think a lot of people have this story where I was the first data scientist hired, and they're like, okay, like do some data science, make our search work well, and I was like, okay, where's your data?
Exactly.
And they didn't have any data.
Show me the data. Show me the data.
And so I was like, well, maybe you should hire me a year from now.
Right. Collect some stuff.
Go collect the data. So I ended up being in charge of kind of collecting the training data.
Yeah.
And so that process actually made me excited about starting Crowdflower to help every company collect high quality training data.
Excellent. And do definitely want to talk more about Crowdflower, but you, this is Sunday at ODSC East, and Saturday was our keynotes, and you were once again one of our top keynote speakers. Your talk was very well received. Can you tell us a little bit about the key takeaways from your keynote address?
Sure. So I'm just such a believer in the importance of training data and the power of a design paradigm that is being called human in the loop, where you have the machine learning do the thing that AI is good at, and you have humans do the thing that humans are good at. So I gave a couple examples of just that design pattern, because I think we see that in almost every real world machine learning deployment.
No, absolutely, and a lot of data scientists out there, especially ones getting into the data science career, tend to forget that it's all about the models, and they're focusing on learning the models, and it's really about training the models. And
I always make this point, but it's such a simple way to improve your models is collect more training data. And data scientists never think of it. They're always trying to get better and better algorithms, and you eke out that
tweak it out another percent.
It's because I think Kaggle competition or something, that's all you can do is improve the algorithms. And
exactly,
that's a cool thing to do. But the real world is not a Kaggle competition,
right? And
you have to actually kind of use every resource at your disposal to make your algorithms work. And
you actually gave two examples I really love. One was around self-driving cars, autonomous cars, and who wants to drive a 99% accurate car to post office? Tell us more about that.
Well, sure. So I was, when I was at the Stanford AI Lab, they were actually starting to build the self-driving car. So I was really watching it. It's really an amazing
really
time.
Early days.
Yeah, it was really early days, and it was, there was this DARPA challenge to just navigate 100 miles in the desert, and
that's right,
like a passengerless car. And so I've been watching, I was riding in the new Tesla and the autonomous mode, and I was thinking it's really, really amazing, right? It's incredible, actually, that, it's almost every time it gets right of where to go. It can follow the road.
Exactly.
But it will definitely kill you if you just let it drive.
Eventually.
It'll kill you. Yeah, I think it'll probably kill you these days, every ride. You drive 100 miles, I think.
Right. That's not a good
Actually, Google has a stat on how long their cars go before the driver takes over. And so that's up to 4,500 miles.
Right.
But actually human, I was reading, goes about 1 million miles before a fatal collision.
So we shouldn't have to worry about the rise of the machines just yet.
When it comes to self-driving cars, I think we'll get there, but there really is such a high accuracy barrier. But that doesn't mean that automation doesn't help you until you pass humans.
Yeah, because you made very good points about that.
Yeah, so it's just hand over the control to a human where the system is confused. Or I think Toyota has a strategy where if they see the car is about to drive into a wall and the AI is really sure, it stops the car.
Yeah.
Right? Exactly. So there's different ways to kind of incorporate humans into your design to actually get the benefits of automation without needing 100% accuracy every time.
Exactly, that's a very, very key point. And you also use the example of the U.S. Post Office, which comes in for a hard time.
Yeah, I think that's just amazing, right? I actually never used that point in the talk before, but I was reading about it. Actually, in '81, they start to automate reading the letters.
Oh wow!
'81, and actually had a picture of the first device.
Yeah.
And I remember in '99, they had a great data set where they had a big contest before the Netflix challenge. So,
who could figure out
automate the reading the handwriting. And what's crazy, so in 81, they automate some of the reading, and then the ones they can't get goes to humans, right?
Exactly.
And actually, that is still true today, right? So it's like 30 years later. I should be able to do this math. 35 years later? 25? I don't
Something
know.
like that.
Something like that.
Yeah.
Anyway, a long time later in the world of
yeah.
computers and
24,
AI.
yeah.
24, all right. So 24 years later, they are still using human-in-the-loop design pattern, right? So they actually still only have about 98%, or it's not 98% accuracy. 98% of the time they use the automation, then 2% of the time they hand it over to a human.
Hand it over, yeah. Excellent. And but tell us more about your. You've got a very successful startup, Crowdflower. Tell us more about that.
Yeah. So unsurprisingly, given what I just said, we we help with the labeling, right? So if you want training data collected in any particular way, what you can do is you can log in and you can basically set up a task that literally goes to human beings, right? So you say, okay, I want you to label all these handwritten pieces of text, like write what the actual labels are. Exactly, yeah, usually it's super time intensive. A lot of times data scientists will do it themselves, or they'll get a bunch of friends. I remember in grad school we'd get pizza and beer and do the
drunk labeling.
Yeah, drunk labeling. Yeah. And
very
so
dangerous.
What you can do is you can get it at a much bigger scale than you can normally get labels at, and so then you can build these models that work better because you have more training data, and then where the models are struggling. And this is an example of human-in-the-loop computing. You can actually send it back to people to kind of label where the model's having trouble. And by the way, you're doing active learning if you're doing that right. So you're actually picking the hardest cases, getting those labeled, feeding it back into the model, improving it. So not only do you have a complete working solution, but your solution's going to get better and better over time without any data scientists involved.
No, a hugely important part of data science that's kind of unsung to a certain degree. And you actually had a super cool conference out in San Francisco in the fall of last year, Rich Data Summit. Tell us a bit about that.
Yeah, so I just wanted to have a conference around the kind of data part in data science, because I think everyone loves the science part, and I was a math major. I mean, I love algorithms, but that's everyone focuses on how do we make a better algorithm. And we just wanted to get together all the people that were actually talking about kind of data cleanup in all its different forms, and how do you collect high quality input data to the algorithms.
No, hugely important, the whole data wrangling thing. It was a great conference, and thank you for having ODSC there. It was a real pleasure. And speaking of ODSC, how's your experience been with the conference so far? This is your second your second year?
Second year. And I was just saying, this is my favorite conference that I go to, actually.
Great to hear that.
And the reason is just that it's, one, I think it's amazing that you have it on a weekend and 3,000 people show up or whatever it was. The attendance is incredible, but I think that weekend thing really filters to people that actually care. Exactly. So there's not a lot of marketing fluff or people
showing up to take a box and it's in the do during the week.
Yeah, I feel like I was talking to my team at the booth, and they were just everyone is just so into data and data science. They're just so passionate that I think that's like an infectious.
Exactly. No, it's a great community you have here in Boston, the West Coast. I'm trying to build it globally, and thanks again for you guys being supporters of ODSC. But let me ask you, speaking of being passionate about data and data science, what excites you about your work and what you guys are doing?
So my favorite thing about my job right now is just it feels like machine learning's finally gone mainstream, where you see every company applying machine learning to whatever particular problem they have. So running Crowdflower, the funnest part of my job is actually going to visit companies and just seeing all the
cool stuff,
surprising applications. That people are doing. Actually here in Boston, we've been working with Beth Israel Hospital to label cancer cells, right? And so you might think why would a human label cancer cells? And they're actually trying to predict from the way the cells kind of organize what type of cancer it is. So they can sequence it, right? But they can also kind of visually just figure it out from the slides, but it's kind of subtle patterns that machine learning can pull out. And so it's so amazing that people all around the world can contribute to label something important, and then cancer researchers actually turn that into important insights.
Yeah, it's hugely impactful.
Amazing.
Great. Well, Lukas, thank you so much again for being a keynote. Thank you for attending ODS East, and can't wait to see you next one.
Thank you.